Okay, today's lesson is 7.4, logarithmic functions using a base of 10 or a base of e. Okay, so if we're going to graph the following three functions here. So log 10x is the same as writing just log x. When we write log x like this, we imply that 10 is the base. So what does this really mean? So if I rewrite this like this, using an x and a y instead of f of x, it means base of 10 to an exponent y would equal x. So for instance, I would have, if y was 0, this would be 1. So I should have the coordinate 1, 0 on that graph. Okay, so we're going to go into y equals, get anything out. So log button is over here, so just hit the log of x. This calculator actually doesn't let us type a little number 10 in there. Okay, I'm going to just zoom 6 and get it on a regular and see what happens. Okay, I'm going to not go very far on my x's down and change my y to -5 and 5. Okay, so we have a table of values to fill in. So you can see that there's errors here. Okay, and so our first point that we have is 1, 0. 1, 0. And then you can see that this is 0.3, 0.301, 0.477, 0.602, 0.699, 0.778. So it's increasing, but it's not increasing very fast. So this is an inverse of what is actually happening on an exponential, because an exponential would have 10 to the x equals y. That would be exponential, and this is a log. So you can see that they're the inverse of each other. Okay, so this is going to have this point, and it's going to slowly and slowly and slowly increase. You can see it didn't even hit a height of 1 yet. And then this way it's going to decrease, decrease, decrease. And you can see that you cannot go into the negatives. So I'm going to go back to my graph here and hit the trace button. And you can see here that that is what's happening. Okay, so we actually are going to have an asymptote right there. You can see that it's not going to cross that line, but you can see on your graph that it shoots down. Okay, what happens if we do the same thing but throw a 2 in the front? So I'm going to go back to my y equals. I'm going to insert a 2 and a graph. Okay, so this looks like it's going a little higher. So I will go to my table of values. So obviously those were all errors. 1 is still 0, but now this is 0.602, 0.954, 1.204, 1.398, 1.556, 1.690, and 1.806. So looking at this, look, it doubled the height. So it is vertically stretching it out by 2. Okay, so I'm going to go that 3 comma almost 1, and then I kind of cross 1. And again, it has an asymptote right on the line x equals 0. It has an asymptote. It doesn't go past that, but you can see that it shoots down. So maybe I will not let you see much on the x-at side, and let's go up by like 0.1s on the x. I don't know if that helps you see more of how it's shooting downward. Okay, so if we put a 5 in front, what is the prediction that will happen? Okay, so change that to a 5 log x. So the prediction is that it's going to get higher. So I'm going to guess that this is none, this is none, this is probably still going to be 0, and this is going to be 5 times that amount. That's my prediction. So error 0, 1.505, 2.386, 3.010, and etc. Okay, so graphing it, so we have the 0.10, sorry, and then you can see at 2 I'm at like 1.5, 6 I'm almost at 4. And again, we're going to have an asymptote right on this line, x equals 0. So between the 3 of them, if I zoom out and you can compare all 3, you can see this vertical stretch. You pulled it apart like that. Okay, we're going to graph the following and discuss the characteristics of each. Okay, so negative 5 log x, so what we had, except for I'm going to insert a negative sign, so that's this button in front. What do we think is going to happen? And it looks like it's upside down of what it was. So that is a vertical reflection over the x-axis. Okay, so x-intercept, so I'm going to hit the trace. No, it's not on there, so I'm going to go calculate the 0. Oops. Calculate the 0. Left bound, so I got to move my cursor left. And then move it right. Enter. And it's still at 1, 0. A y-intercept, what do you think about these y-intercepts? It's never crossing that line. So there's going to be none. The domain, so the domain goes from 0 and on. So from 0 to infinity, but I don't want to be exactly 0. Or you could write it like that. The range, so you could see that this is going to go down, 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 and this is going shooting up, up, up. So negative infinity to infinity, or y is an element of all the reals. And the end behavior, it's from quadrant 1 going into quadrant 4 decreasing. Okay, next, 12 ln of x. So ln is the same as doing log with an e. Okay, so 12, and then this is the ln button here now. ln of x, so it should look like that. I'm just going to go back to my zoom 6 here. Okay, so I see that, well, 12 made it stretch really far. So I would like to, I don't really need to go much negative. I would like to go a little higher. So I can see that it reaches quite high. I will go actually a little bit more. So that you can maybe start to see that it's arcing and going and going. So that's pretty high. Okay, so x-intercept, so calculate the 0. Left bound, I think it's 1, so I'm just going to go that to 2, and then it is at 1. Okay, what do we know? What do we know about the y-intercept? It is not happening because it's going to approach the asymptote, so it's never going to cross that line. And domain will be the same. And same with the range. So domain 0 to infinity, and then range forever and ever. Okay, this time our end behavior is different though. We're going from quadrant 4 to quadrant 1, and we're increasing. Okay, next one, negative 4 ln of x. Okay, so there's that equation. I guess I could change my window. I obviously don't need as high, so I'm going to change this to negative 10 and 10 just to see what happens. Alright, that looks pretty good. Okay, what's the prediction? Let's go trace 1, and that is the x-intercept. And it's going to shoot up and never cross that line. So no y-intercept. Domain looks like it's going from 0 to infinity. So it's the same. Range, it's going down, 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 up, up, up. And then we're going from quadrant 1 to quadrant 4 as we move right. From quadrant 1 to 4, and we're decreasing.